Distributed computing is everywhere in our life. The superstar Bitcoin is based on blockchain, which is an application of distributed computing. When you're using BitTorrent, your downloads come from many seeds from all around the internet world. When the laboratory needs tons of computing for an experiment, they may gather computers in the network to help out their work. Now, we'll take you to figure out the magic of the distributed computing. The first problem we may consider is the multiprocessor cooperation. Imagine a task is distributed to different computers in the network. How do they cooperate to work on the same task? The first thing we want to do is to divide and allocate a task. When it comes to work allocation, our goal is to do it fairly as well as efficiently. To tackle this issue, we need to determine the load on each processor. The load is made up of execution cost and communication cost. They represent the time needed for running through the program and transferring data. Taking consideration of these two factors, we can calculate the loads for each processor and assign proper tasks to them. Here, the letter E stands for the execution time, and the letter C stands for the communication cost, while the matrix A and L determine whether the computers are assigned tasks and linked to each other. After this calculation, we may know which computer the task should be assigned to. What's more, a problem caused by multiprocessor is a time difference. If the clocks in the distributed processors are different, the job sequence could be in a mess. One solution is the Lampson mechanism. Let's say now we have two processors and each of them is running at different clock rates. In a unit time, for example, A takes 5 times and B takes 15 times. So when A transfers a message to B and gets the response, there would be a problem in the timeline. To solve this problem, we introduce the Lampson clock in the two processors. When they send out a message, the message will also carry the Lampson timestamp. For example, both A and B start the task at time 0. A sends a message to B at timestamp 5. The message takes 2 unit time to reach B, and B's timestamp is 45 right now. The Lampson logic clock in B checks that the current local time 45 is larger than the sending timestamp 5, which is no problem. Then it takes 2 unit time for B to process the data and respond it to A. And this message also takes 2 unit time to reach A. Now the Lampson logic clock in processor A finds out that the current local time is smaller than the sending timestamp. Then it will change the local time right after the timestamp. In this way, the whole system of processors may maintain a correct logical timeline and cooperate in order.
I'm going to introduce data synchronization and distributed data, which is a significant part of distributed computation. Data synchronization is the process of transfer data from a source to a target data storage and vice versa. The operation of the data synchronization should be done at the same time. As an analogy, it should be a mirror image of the current operation both sides. It means that the data should keep consistent during the synchronization. The technique is fundamental to a wide variety of applications. For instance, we can read and modify the same Google Docs at the same time on different devices. It is very convenient to do that, and because we don't need to modify the same parts on many devices. However, it still has a lot to improve for large data processing. Then, I will introduce the structure of the application of data synchronization, the distributed data system. It is a client and server system with many databases. Firstly, the client will call the server and send the data. Then, the server will receive the data and return all the newest data to the client. Then, the client will delete the data encrypts the storage data. For the optimized system, the server will only send the changed data back to the client. Let me introduce the advantages of the system. First, it can speed up the processing and save time. The file can be saved in the nearest database. Second, availability. The server can distribute data to different databases. If one is broken, others can still be used. Therefore, the data will not be lost. Third, the data can be shared. As I mentioned before, Google Docs is a good example. People can share the different data from the system. For disadvantages, first, when updating the system, there are some data error and lost. Some parts may not be replicated, but some are replicated for many times. Second, the amount of data is huge and the system is complex. It is hard to synchronize data and control the system.
Paxos is an algorithm used to solve the consistency problem in a distributed system. That's the process of agreeing on one result among a group of participants. Paxos describes the actions of the processors by their roles in the protocol, which are the clients, acceptors, proposer, learner, and leader. In the very basic Paxos algorithm, we only count the acceptor, proposer, and learner. The algorithm basically consisted of prepare, promote, propose, accepted, accept, period. Next, let's go through the process of basic Paxos. First of all, proposer choose a new proposal number n, broadcast the prepare function to all servers. N can be the server ID plus the timestamp. Then the acceptors will respond to prepare function with two return value. One is accepted proposal, another is accepted value. If n is greater than minimal proposal, then we assign n to minimal proposal. The accepted value is stored in the system before, which can also be nothing. This is what we call the promise from acceptor. When response is received from the majority, if any accepted value returned, then replace the value with accepted value for the highest accepted proposal. Next step, broadcast accept function to all servers or acceptors. There are two parameters in this function, n and value. Later on, the acceptors respond to accept function. If n is greater than minimal proposal, then assign n to the minimal proposal and accepted proposal, and replace the accepted value with the value from the accept function. Finally, return the minimal proposal to proposer. When response is received from the majority, it means the proposal is accepted. If the return value as a result is greater than the initial n stored in the proposal system, it means there is most recent proposal in the distributed system. So we go to the next step. So we go to the step 1 and do the whole process again. Otherwise, the value is chosen. Ultimately, the learner will record the result and the whole process into storage for the security. Now let's go through an instance. This is a timeline. There are 5 servers in total. 3 servers received the prepare with n equals to 3.1, and the majority of the whole servers, 3 of 5, send the accept function with accepted proposal, which is 3.1, and accepted value, which is x, and x is the previous value. A proposal is finished and 3.1 is chosen. Later on, a new proposal with n equal to 4.5 are the majority accepted, because the previous accepted value is x and the value in the accept function should be x nor y. When the major acceptors come to the consensus, the proposal 4.5 is chosen.
After the introduction of many aspects of distributed computing above, let's look at a fairly important part of, actually, all computing technology, security. It is quite similar for security to computing and security for a house. It seems like the gate is the main way to get into a house. However, windows and other potential entrants could also be accessible. Distributed computing is like the magnifier to this problem, for distributed computing has many participated computers in processing. It is just like there are many houses, and thus it will be more difficult to defend the whole system against intruders. Security problems have haunted the computing domain for many years. Back to 20th century, there were a number of stories about computing security, such as the cuckoo's egg and worms. In distributed computing, failures in security could lead to even greater losses for the appliers. With more and more applications using distributed computing, challenges have also risen with opportunities. In the past, security problems were only located in one device, for data and processing applications is only usable at one place, so the security solution is direct and simple. But distributed computing security is much more complex, and it's like sending a car for maintenance. The car itself needs to go to many different repairing companies, and people need to make sure that every company is doing a fine job. In the next part, I'll give a brief list of 5 main security problems in the process of applications of distributed computing. Problem 1. The weak certification system of users. Certification is the basis of most security systems. Organizers need to certificate the users and their computing environment are truly as their declarations. The ways of certifications nowadays depends on the password and checking the IP of the users. However, password during transferring is in the form of clear text and IP is easily disguised. People need better ways to certificate in the usage of distributed computing. Problem 2. Managed tools. Application using a distributed computing environment needs to be managed in many aspects such as public certifications, access control, etc. Problem 3. Prevention in Internet using environment. With Internet taking a large part in distributed computing, this system needs to face the potential danger of attacks from all over the world. This will also need suggestions of cybersecurity experts to make the system work. Problem 4. Physically access. If an unauthorized people access the computer's operating system or the network device, the whole system will face the danger of being accessed unauthorizedly. Problem 5. Education and advancing technologies. With computing technologies melting into society, the fast advancing pace will be a challenge for the organizers of distributed computing system. For hackers will be more likely to find out the bugs of the system before its program does so. So, it may be hard to fix the bugs before it is exposed. These 5 aspects are only representative problems of distributed computing, and to conclude, there is no universal solution for different operating environment and network systems. Global business using distributed computing has connected internal networks together, thus bring more danger. Yet, many solutions have been raised by computing experts while distributed computing being more commonly used. One solution raised by experts aimed to solve the security problem started at solving the 2 classes of distributed computing: security of host and security of distributed applications. The experts have given out the trust domain-based terminal model. This model has distributed applications which participate in establishing local systems access control policies, should solve the requirement of guaranteeing integrity and confidentiality of distributed applications. Also, a proposed trust domain-based terminal architecture to meet the remote attestation of terminal systems. With these 2 proportions, this solution can deracinate the malicious host problems fundamentally.
Distributed computing is beneficial for both sides. Not only for the developer but also the people who run the processor can get money. For example, the Bitcoin mining. Distributed system combines all available CPUs to achieve the same computing ability as a huge supercomputer. The cost is much cheaper than the current cloud computing service. It's very efficient for some programs that require a lot of computer power, such as machine learning, 3D simulation, and biocomputing. However, there are three key challenges in running code on end-user devices. The first one, which is also the most difficult one, is to get as many people as possible involved into the whole distributed system through utilizing their devices. And no one is willing to provide their PC to do the computing for free. For this reason, cryptocurrency was born for award each participant. The cryptocurrency makes machine-to-machine payment possible. In this way, you can pay a stranger a sum of money to appreciate him for borrowing his idle part of CPUs to run your program. The second challenge is the relative low performance of PC to the professional one. To solve this problem, we see some projects being built in parallel to run code on multiple machines at the same time. Anchor Network lets users pack their code into blocks and submit to the network separately, and then assign them to different machines by the job scheduler. DCP automatically assigns subtasks of the application to each machine in the form of JavaScript objects executed in the web workers. In addition, DCP is very smart. It uses an API called WebGL to access image processor of end-user devices to further improve efficiency. The third challenge is that end-users' devices are not trusted hardware. There has been great progress in the application of SGX, which is the trusted hardware environment built in the chip. Eventually, all the tokens will flow to the real market. The more people admit it, the more enthusiastic the gamer will be. Naturally, the whole distributed ecosystem will become more dynamic, so the developers can achieve what they initially envisioned.